All right, guys, hello again. Today I'm going to go over section 9.1.1. We're beginning chapter 9. It's your last chapter of 6th grade math. One more chapter to go, just a couple more concepts. So today's lesson is going to be talking about the volume of a rectangular prism. So we're talking about how much does it hold, is kind of the name of the lesson. So to start off talking about volume, we first of all need to understand dimensions, okay? So you can see on the screen here, we've got three different examples here. The first one on the left is just a single line, right? So it's got length or it's got height or whatever you choose to label it as, but it's only one dimension, okay? The second example right here is a square. So this one has got a height or a length, it's got a width, so it's got two dimensions, length and width. Then the third example right here is a three-dimensional box, right? Just the name of saying three-dimensional tells you it's got three dimensions, right? So in this case, it's got width, it's got length, it's got depth or height, however you want to label them, but length, width, and height, it has all three of those, which means it's a three-dimensional object. This is important to understand because when we're talking about volume, we're talking about three-dimensional objects, okay? So I want you to have this down in your notes as one of your vocabulary words. It'll probably be, well, it will be on your Chapter 9 Math Notes quiz. So if you took notes before on Chapter 8, the Chapter 8 Math Notes quiz was probably super easy for you. So I'd suggest you write this down so you have it when you're ready to take that quiz, okay? But I want you to have a definition for three-dimensional, an object that has height, width, and depth, okay? That's the definition of a three-dimensional object. The second vocabulary word I want you to have down is volume. Volume is a measurement of the size of the three-dimensional region enclosed within an object, okay? So basically, what that means is if I take this box, for example, I've got a box of light bulbs, right? You would agree with me that this is a three-dimensional object. It's got a width, it's got a height, it's got a depth, okay? So this is a three-dimensional rectangular prism is what we call it, okay? And so if I wanted to find the volume, I would basically have to open the box up and fill it up with whatever unit of measurement I'm using, and then I'd have to determine how many units fit inside of that box, okay? And so there's a specific formula we want to use in regard to the volume of a rectangular prism. There's different formulas depending on the kind of shape you're using. In this case, we're talking about rectangular prisms. And so the formula that we're going to use is volume is equal to length times width times height, okay? And again, we just represent it by the variables. And you know when the variables are right next to each other like that, it means they are multiplying, right? So again, volume is equal to length times width times height. And again, that is just for a rectangular prism, okay? And the other thing you need to mention is that volume is always going to be cubed. Okay, what that means is if you recall back to learning about area at the beginning of this year, we really emphasized that area is always squared, right? It's always in square units. Well, volume is always in cubed units, which means you write it to the third power. When you're doing squared, it's to the second power. When you're doing third, it's to the third, or cubed, it's to the third power, okay? So let's go over an example of this, and then we'll be done with this, okay? Try to make it short and sweet. So in this example, Caesar the gorilla and Larry the unicorn, they are architects. Probably didn't know that. And they designed a building floor plan right here. And so each cube or each square represents one cubic unit, okay? So if we're looking down from the top, right, and we're looking at the floor plan from above, basically we can say, well, it looks like Larry and Caesar created an office space that has it's got 6 offices, so it's got 6 cubic units, right? Or 6 units cubed is how I could say that. And that's just the first floor, right? So if I say, I've got a little representation here that represents those 6 offices, right? So you can see the 6 individual units. You can see that there is a width, a height, a depth, right? So you've got a width of, or a length of 3 times a height of 1. 3 times 1 is 3 times a depth of 2. 3 times 2 is 6, right? So, and if I look at it, and on the example on the screen here, I've got 1, 2, 3, 4, 5, 6 offices, right? So 6 cubic units. Now, if I took, say, Larry and Caesar got creative and decided, you know what, we're going to not have a single-story building, we're going to make a 2-story building. And so they added an entire second level to their building. So now their building looks like this. Well, if we wanted to figure out the formula, we would do the following. We'll say, okay, volume is equal to length times width times height. So let's go ahead and we'll say, okay, well, we've got a length of, we'll just say this is my length. I've got length of 3, okay? So I'll plug that in. Times a width of 2 times a height or a depth of also 2. Okay, so volume is equal to length times width times height, which in this example is 3 times 2 times 2. So when I'm following order of operations, when I'm multiplying, I just go left to right. So here I got 3 times 2 is 6. 6 times 2 is 12. And then I have to make sure I put my unit on there. In this case, we're just talking about units. And it's going to be units cubed. Okay, so the volume of Caesar and Larry's building, once they expanded it to 2 stories, it's 12 units cubed. And I can see that by looking at the shape, right? I can count it off. 1, 2, 3, 4, 5, 6. And if I flip it over, there's 1, 2, 3, 4, 5, 6. 6 plus 6 is 12. 12 units cubed, right? And so it would be the same if they went on and added a 3rd story. We could then calculate using this formula how many units cubed the building would be at that point. So that's basically volume. As we're kind of coming down the stretch here, we're going to do the last couple concepts. I'm going to try to keep it easy on you and not require a lot of work on your part as long as you watch the videos and kind of understand how to do it. What I'm going to have you do for this homework is just click on the text entry tool in Canvas and tell me in your own words, what is volume? Okay, explain it to me in your own words. And if you do that, then you get the points. Okay, so we'll try to keep it pretty plain and simple moving forward. And I'm also going to try to get most of the assignments for the rest of the year up pretty soon, so you can just kind of work through them and hopefully get done early, right? So hang in there, let's finish strong. We just got a couple more weeks. And make sure you keep up on your work and check Canvas every day, and you'll be fine, you'll be good to go, okay? And as always, make sure you text me if you need help, guys. I'm available pretty much anytime, so I'm happy to help whenever I can, okay? Be good, talk to you later, bye.